Effect of load on muscle contraction. Principle: a change in muscle contraction can be seen by changing the time of application of load in relation to contraction. In this experiment, we study the effect of application of load on muscle contraction. We apply load to the muscle at different times in relation to muscle contraction: before contraction, preload or free load, during contraction, and after contraction, after load. We observe the effect of each application of load on muscle contraction. Procedure: to test the effect of load on the muscle, we use an afterload lever instead of a righting lever. We add a weight of 10 grams to the lever around 1 cm from the fulcrum. The fulcrum is the hinge of the lever. The arresting screw must just touch the lever blade. When the screw is in this position, the load does not act on the muscle when it is relaxed. The weight acts on the muscle only after the muscle contracts, that is, shortens. In this position, the muscle is said to be afterloaded. We adjust with 80 grams weight at the fulcrum. We loosen the afterload screw. Immediately, there will be a drop in the lever as the weight acts upon the relaxed muscle and stretches it at rest. The muscle is now free-loaded or preloaded. Now we record the contraction on the moving drum by stimulating the nerve. We keep decreasing the weight on the lever and record each contraction. We use a different point of stimulation for each contraction but keep the strength of stimulus constant. Now let's analyze the graphs. This is a graph showing an increase in the afterload on a moving drum. You can see that as the afterload increases, the height of contraction decreases and the latent period increases. In contrast, in the graphs showing increasing preload, you can see that the height of contraction increases with an increase in the weight. However, after a certain increase in the weight, the strength of contraction reduces. Even if recorded on a stationary drum, the findings are similar. Let us now discuss why this happens. In the afterload state, the muscle has to contract against the increasing weight. Hence, as the weight increases, the strength of contraction decreases. The latent period increases due to increased inertia of the lever because of the extra weight. In the preload or free-load state, the load acts on the muscle before the muscle contracts. The load stretches the muscle in its resting state. This increases the length of the muscle fibers. This increases the force of contraction of the muscles according to the Frank-Starling law. The Frank-Starling law states that the force of contraction of the muscle is directly proportional to the initial length of the muscle fiber within physiological limits. This graph shows the intensity of muscle contraction at different sizes of the sarcomere. We can see that the intensity of contraction increases with an increase in sarcomere length, till the sarcomere reaches a length of 2.25 microns. Any further increase in sarcomere length decreases the force of contraction. This is because 2.25 microns is the physiological limit of the sarcomere. In the frog nerve muscle preparation, the force of contraction increases with an increase in the preload up to a limit. After that,